Hello students, welcome back on SC Smart Classes online portal. Dear students, today we are going to discuss Standard Mathematics first year second sem Fluid Dynamics. It's our video fourth part. It means fourth lecture of our video. I will tell you a question. Okay, it's an important question. First of all, I will understand you that what's the question saying, and after all we will get the solution of this question. Okay, so a question is a velocity field is given by q equal to minus x I cap plus y plus t j cap. Find the stream function and streamline for this field at t equal to 2. We have given that a velocity field, okay, q is equal to this, and the question is saying that find the stream function. For this, what will be the stream function and streamline equation when at t equal to 2? What will be the stream function and streamline equation at t equal to 2 for this given velocity field? Okay, so solution will be, we have the first value of this coefficient of I cap, it will be minus del psi upon del y. It will be denoted by u by CR equation. What is the value of this? Minus x, coefficient of I cap, and del psi upon del x, what is the coefficient of j cap? Y plus t. Therefore del psi upon del x, del psi upon del x will be y plus t. Equation number 2. After getting these two equations, we just integrate both equation first and second. When we will integrate first equation, we will get that with respect to y, it will be psi and minus x minus x, and when we will integrate partially with respect to y, this minus cancel out from this minus. When we will integrate this with respect to y, we will get that x into y plus tx plus f1 x plus t. It will be equation number 3rd. Similarly, we can integrate equation second, we get equation number 4. Now f2 must be a function of t alone. Okay, here your f2 function a function of t alone. Okay, otherwise 4 will not be satisfied. Then f1 will be equal to tx plus f2. Thus we can write these equations psi equal to xy tx plus f2 t. We will get equation number 5. Now in the question was he was just asking in the question streamline equation at t equal to 2. Therefore we have to just put in equation number 5 t equal to 2. We will get the equation of streamline. Okay, then streamline psi equal to constant. Previous derivation we have to just prove it. Okay, are given by what? X plus y plus 2. We can take out x common outside, y plus x, y plus t will be remain in the bracket, and we can put the value of t equal to 2 here. It will be constant because psi function is constant. So what is the value of psi? Constant, and we will take x outside, we will get y plus t. What is the value of t? 2. We will get this equation. Okay, it is the streamline equation, and this equation is known as, which is an rectangular hyperbola, this equation. Okay, now we will discuss next topic. Okay. Next topic is source and sinks. This is the most important topic for your exam. Okay, source and sinks. It's asked from in your examination many times. Okay, simple source and sinks. Okay, so let's understand it. What is this source and sink? If the motion of a fluid, let you have any port like this, in it there is fluid. if the motion of a fluid consisting of symmetrical radical flow, and this fluid is consisting symmetrical, okay, then in all the direction proceeding from a point, and it will be proceeding from a point in all the directions, okay, it is known as simple source. If however the flow is such that the fluid is directly radically inward, if fluid is directly inward, then it is known as sink. In simple way you can say that if source means, I just tell you in my first lecture that what is source of light, sunlight, okay. Source is that point from where the sources are proceeding, okay. These are known as source. And sink is just opposite of this writing here about the both of these, okay. And next, a source implies the creation of a fluid. Source implies the creation of fluid, okay, at a point, creation, whereas a sink implies an analysis of fluid in a point, this type, okay. Is that clear? In this lecture it is sufficient for this lecture, and after all we will discuss in next lecture, okay. If you have any doubt from this lecture, you can give your comment in comment section, then it's sufficient for this lecture. See you next time. Bye bye. Thank you.